you know. Let me make sure this. Let me see.
Jeez. Was that loud?
That was the loudest thing. No one else heard it.
I hear myself, I'm sorry.
Okay. Yeah, alright, I'm not losing my mind. Okay. Yeah, I just want to make sure I was doing this right. If you guys want to write this down in your notes, feel free. This is how you would do it from the base perspective. So if this question was asked about ammonia, right? So what concentration of NH3 needed to make a buffer with a pH of 9, and we had 0.1 NH4Cl, right? So if we do this from the base perspective, most questions on the test actually are from the acid perspective, just like this. But this is the same exact equation, just everything's kind of flipped for the base. POH, PKB, this is your conjugate acid over your base. This is not on your reaction sheet, I don't believe, or your equation sheet.
No, it's not.
Yeah, so if you want to write it down, go ahead. But you can always use this, even from the base's perspective. You just have to convert this from KB to KA using KW, and then you still can use this. You just have to plug the numbers in correctly. So, not trying to confuse you, just trying to give you more ways to do these problems. So it's up to you. All right, I'll give you another minute, and then we'll see. You guys ready? So chapter 16, 10 through, no, that's not right. 10, 11, 14, 16, not 16, what is wrong with me? 19, okay.
No, that's only base.
19 through 22. Now, that seems like a lot. Hold on one second. But 10, 11, and 14 are just one question. Sort of. Yes, question.
How do you know, for the fraction, how do you know which one's on the top and which one's on the bottom? Yeah, I don't know what that is.
Really?
Yeah.
What's that?
I don't know.
You're killing me right now.
They don't, Luke doesn't know which
No one knows what HA is?
Well, I don't know which one's on the bottom.
So this is just a general formula. HA is a weak acid. It dissociates in water to get H plus and A minus. So A minus is the conjugate base. So for example, HF would be HA, F minus would be A minus. As far as the B's are concerned, NH3 is the B, that's base. When it's in water, it gains a proton, and NH4 plus would be BH plus 1. So, I guess, sorry if I seemed hinking back there, but you guys need to know that. You need to know, because otherwise you can't do this. So, again, chapter 16, 10, 11, 14, 19 through 22. Those are all buffer questions.
Wait, I got
I was getting 1.82, so my decimal was wrong.
1.82, that's a good number. I have that number written down. It's not the answer, but I have that number.
0.0549.
Wait, is it .182?
Nope.
Shoot. Wait, what'd you get?
0.0549.
I got .74.
Are you guys using an ice table or the Henderson-Hasselbalch equation? Okay, that's fine. I'm just gonna go. I'm just gonna go right to this instead of messing with the ice table. You could do the ice table though. Do you want me to show you both ways? I'll leave it up to you. Does anyone want to do the ice table? Do both ways. All right, let's do this first.
Yeah.
Do this first. Okay. All right. So we put 5 in for pH. 4.74 is for pK. Now I'm skipping a little step here. The Ka would have to be given to you. I wrote it down in the problem, but I didn't write it on the board because we just went over that. So on an AP test, they would give you Ka of acetic acid 1.8 times 10 negative 5. They'd have to give that to you. So now you take the negative log of that to get pKa. All right. Plus log of A minus is this here. This is your A minus. This is your conjugate base. Conjugate base. So 0.1 over x. So, like Skylar said, the fractions there, that's the whole ballgame. If you put the x here and the 0.1 here, then you're gonna be wrong, right? So now we can maybe set it up, but how do we solve for x? All right, so what would we do? Now it's a math problem. What do we do?
Subtract the 4.7.
Okay, subtract 4.74. Subtract 4.74. So we get 0.26 equals log of 0.1 over x. How do we get rid of log?
Raise it to 10.
Raise it, right, so 10 raised to the 0.26 equals 0.1 over x. Right?
Yeah.
On your calculator, you can just hit second log, 0.26. Same thing. Same thing. Okay, so when you do 10 raised to the 0.26, that's 1.82 equals 0.1 over x. Cross multiply, it's going to be 0.1 divided by 1.82. So x equals 0.055 moles per liter. So it's really just a math problem at that point, as long as you know where the 0.1 goes. So the buffer questions really aren't that bad as long as you remember to use this and you can solve it, right? As long as you remember to use the equation and you put the numbers in the right place, then it's just a math problem. And maybe that's harder, I don't know, but you guys are all good enough where you can do this, or you just need practice, right? When I say good enough, I mean good enough at math, not like good enough as far as people are concerned.
I signed up to learn chemistry, not math.
I learned.
You're
I
good
signed up
people,
for this class.
whether you're good at math or not.
Explosives.
All right.
What does that mean?
Now, let me show you the ice table quick, and then I gotta get to titration. All right. So here's how we would do it. HC2. I'm gonna go real fast. So here you go. H plus C2 H3 O2 minus ICE. What is this? Is this the X? All right. 0.1 0 or X 0.1 plus X X. So this would be technically X minus X, right? Because there has to be a change, so maybe we should do it this way. So if this is like, we don't know that, and this is minus X, and this is question mark minus X. This is just how I do it. So 1.8 times 10 to the negative 5 would be the Ka, is equal to X times 0.1 over question mark, right? So what do we do?
Multiply by question mark.
Hold on a second. Hold on a second. You can't do this. You can't do this.
If you believe you can.
No, it's two different variables. This is like y. This is like y. Or any other variable.
But see, in math, that's when you solve.
Yeah. I'm not going to mess around with that.
X and a huh?
Never mind. I'm going too fast. My mind's going too quick. You can't actually do it this way. Just use this. Moving on.
His brain's working hard.
Moving on.
There's an exclamation point in the calculator. We can use that instead.
Yeah, alright, next time. Alright. So there's your homework. I'll send that out again later. Here we go. And I do have another one here, which we will do tomorrow as a warm-up. Alright. Okay. Titrations. Here we go. I'm going to introduce this for 5 minutes, and then we'll get out of here. Alright. Let's talk about what we know. What does a titration curve look like?
S.
An S. Okay, it looks like this. What's on the y-axis?
No.
pH.
No.
pH.
That one.
What's on this axis? Kind of depends.
Fine.
Volume of NaOH, let's say. Volume of base. Alright, let's say 0. Let's say 50. pH 0. pH 14. Right in the middle of that vertical part should be 7. Does anyone remember what that's called? Endpoint or equivalence point? Endpoint / equivalence point. Now, if we were doing a titration with a strong acid, strong base, this is what it would look like. So if we had HCl plus NaOH, this is what it would look like. You're going to learn there's two other titrates. So the AP test doesn't even really mess with this. It's too easy. They ask questions about a weak acid, strong base, or a strong acid, weak base, which we'll get into tomorrow. I'm just going to review what we've already learned in Regents. So if you have HCl, so here's your flask down here, here's some HCl, and then you got your burette, and you're dripping NaOH into it. When it's neutralized, you will have salt water, and that's a pH of 7. So again, this is all kind of review, just going over it again with you. As you add base, your pH will increase. Yes, sir.
What's going on, Coach? Here's your scholar athlete pins.
All right.
Anybody 90 or above.
Yep.
You just want to, like, I usually poke them on the certificate form.
Yeah, we'll do that. Yeah.
Okay.
All right, thanks.
Yep.
Appreciate it.
No problem. Elizabeth's back from Florida.
Okay, so, if this was the chart given to you, it looks like the equivalence point we'll say is 25 milliliters. So what that means is if the concentration of your acid and base are the same, so let's say they're both 0.1 molar, I would need 25 milliliters of NaOH to completely neutralize 25 milliliters of HCl. Hopefully everything I'm saying is making sense because it is review. pH is 7, the equivalence point, end point. Now, how do we know in a titration in lab when we reach that point?
It changes.
What changes?
The color.
Good. So the indicator changes color. Phenolphthalein is typically what we use for strong acid, strong base, and it's a very light pink color. I think you guys remember that. You can also use bromthymol blue. It'll be like greenish. Who did that in the equilibrium? Who was that? Yeah. So different different indicators turn different colors at different pHs. We're going to talk about that. So if we want a neutral solution at the end, phenolphthalein, bromthymol blue are pretty good for that. All right. This is what it looks like when you do a strong acid, strong base. Down here, you have very low pHs. Up here, you have very high pHs. Why do you think it looks like an S? Why isn't it just a linear relationship? What's happening down here that's not happening here? Or what's happening here that's not happening here? Like, what's the flat part mean?
It's the same.
pH isn't changing as rapidly, right? When we initially add the NaOH and we swirl this, what's happening to it?
It's getting energy.
So when I'm adding OH minus into H pluses, I add some drops, it flashes pink and goes away. What's happening? It's neutralizing. So the acid is withstanding pH changes until you reach the point where it can't neutralize anymore, so it spikes. And then once you go way past the end point, it's the same exact. There's no H pluses to neutralize those OH minus, so it stays around a 14. Okay? One more thing I want to mention. At this end point, my H plus concentration will equal OH minus. But that only is true for strong acid, strong base. Alright, I'm not gonna really go over this stuff again tomorrow. I'm just gonna refer to it and say, remember yesterday? So that's only true if both are strong. If one's strong and one's weak, that doesn't work. Alright, so we're gonna talk about that. And the endpoint will shift. Your endpoint isn't gonna be a 7, it's gonna be a 9, or it's gonna be a 4. It will shift. Okay? So I'll stop. So the bell's gonna ring. That was good to kind of get the ball rolling. And tomorrow we'll go over the homework and